These are the video notes for dilations and scale factors. A dilation is one type of transformation, and in a dilation, a figure is multiplied by a scale factor, and that will make the figure bigger or smaller, depending on what the scale factor is. The way that you can represent a dilation algebraically is by showing the scale factor times x and the scale factor times y. So if the scale factor is a, we would say that it's a times x, or ax, and a times y, or ay. If the scale factor is greater than 1, so I'm going to say if I'm going to use a to represent the scale factor. If it's a number bigger than 1, then it's going to make the scale factor, then it's going to make the figure bigger. Examples of this would be if it's like 3, a scale factor of 3, so 3 times the x value and 3 times the y values would make everything bigger. Or something like 4/3 times x and 4/3 times y. A scale factor of 4/3 also makes the figure bigger because 4/3 is bigger than 1, right? It's 1 and 1/3. If the scale factor, so if it's between 0 and 1, so the way I wrote this is if my scale factor a is greater than 0 or less than 1, that would make the figure smaller, because everything is getting multiplied by a number less than 1. Examples of this would be if you have a scale factor of 0.8. So it would look like this. Of 2/3, because 2/3 is less than 1. Let's look at a couple of examples. In the first example on the left, we have the original rectangle ABCD, and then the new rectangle, which is A prime, B prime, C prime, and D prime. The prime symbols, right, these little tick marks that you see next to the letters, that is telling you that that's the new figure. To find the scale factor, we're going to pick one pair of corresponding points. So I can use point C, for example. And the original point C is, the coordinates of that point are an x of 3 and a y of 2. And this is my original. And the matching point, or the corresponding point, is C prime. And the coordinates of that point are an x of 6 and a y of 4. So C prime is x of 6, y of 4. And to find the scale factor, I'm going to label it SF for short. I'm going to do the new divided by the original. And I can use the x values or the y values. So in this example, I'll use the x values. So I want my new x value divided by my original x value. My new x value, that's the x value of C prime, so that's 6. My original x value, that's 3. Six over 3, I'll see if I can simplify that. Yes, 6 can be divided evenly by 3, so it's 2. So my scale factor is 2. Then my algebraic representation, each xy value is going to be multiplied by the scale factor, which is 2. So it would become 2 times x, or 2x, comma, 2 times y. Let's look at the next example. If the figure is dilated by a scale factor of 3/4, what will the coordinates of the new point T be? So in this example, I think I mislabeled it, but T prime is actually the original T. So here's our original. So original T is an x of 5 and a y of -5. And to find where T prime would be, or actually the new point T, we'll just call it new T, we're going to multiply each of the x and y values of this point by our scale factor, 3/4. So it would be 3/4 times 5 for the x and 3/4 times -5 for the y. And this would equal, I'm going to show you out here, 3/4 times 5 is, 3 times 5 is 15 over 4. And I'm just going to leave it as an improper fraction for now. And 3/4 times -5, 3 times -5 is -15 over 4. So that's the coordinates of my new point T. All I did was I just multiplied the original points times the scale factor. For the algebraic representation of this dilation, each xy point gets multiplied by a scale factor of 3/4. So it's 3/4 times the x value and 3/4 times the y value.